5-minute odds ratios. Risk is the probability of an event occurring. Odds are the probability of an event occurring divided by the probability of an event not occurring. Let's start with a sample of 200 people and measure their exposure to a risk factor. There are 100 people exposed and 100 people not exposed. We follow them over time and look at the proportion of cases in each group. The probability of developing disease in the exposed group is 0.5. The probability of developing disease in the unexposed group is 0.25. The ratio of these probabilities is the risk ratio. 2. Now let's convert these probabilities to odds. We take the probability of the event in both groups and divide it by the probability of the event not occurring, and we end up with odds of 1 in the exposed group and 1/3 in the unexposed group. The odds ratio is the ratio of the odds in the exposed group to the odds in the unexposed group. So we simply divide 1 by 1/3, and we have an odds ratio of 3.00. We interpret this by saying subjects who were exposed had odds of the outcome that were 3 times as high as subjects who were not exposed. We can calculate odds ratios from a 2x2 table. Here exposure is in the rows and outcome is in the columns, and we label the cells A, B, C, and D. Odds simplifies to cross multiplication. A times D over B times C. In this case, this works out to 3. 3 is our point estimate for the odds ratio, but it's always good to include a measure of precision. Here, we've calculated the confidence interval for the odds ratio by hand, but if your instructor is kind, they will just let you have the computer do the work. And so we would say that subjects who were exposed had odds of the outcome that were 3 times as high as subjects who were not exposed. But we'd expect the actual odds ratio to be somewhere between 1.65 and 5.47. And if the odds ratio was significant, we would expect it to not include 1 in the confidence interval. Now, just like with risk ratios, you have to be careful about how you interpret odds ratios less than 1. If an odds ratio is 0.30, for example, we would say that subjects who were exposed had odds of the outcome that were 0.3 times as high as subjects who were not exposed. You can't say 30% lower. This actually is 70% lower because you have to subtract from 1. So if you wanted to talk about lower odds, you could say subjects who were exposed had 70% lower odds of outcome compared to subjects who were not exposed. And then remember finally that odds ratios are a good estimate of relative risk when the outcome is rare. But here we have a common outcome. And so odds greatly overstate the risk. We had a risk ratio of 2 for this example and an odds ratio of 3. Here we've changed the example to have a much lower prevalence rate, 75 out of 1,550. Now the odds ratio ends up being a much better estimate of the relative risk because the outcome is rare. So thank you for listening. We made it in under 5 minutes. Be sure to check out the next video, which will be odds ratios in case control study. Thanks for watching.